This is Chapter 3, Section 3, Part 1, Rate of Change. So we're going to talk about rate of change in this video, which is also known as slope. So we'll be watching a second video on Monday about slope. So this first one, the rate of change is a ratio that describes, on average, how much one quantity changes with respect to a change in another quantity. So early on in a chapter, we talked about independent and dependent variables. The x is the independent variable and the y is the dependent variable. So make sure you write those two variables in those spots. So how do we find rate of change? Well, you take the change in y over the change in x. So make sure you write this part down. It's always the change in y over the change in x. So we're going to use this table to find the rate of change and then explain its meaning. So that's important. So we have in the first column of x, the number of computer games, and in the second column is the total cost in money, in dollars. So we have 2 computer games cost $78. 4 computer games cost $156. And likewise, 6 games cost $234. We're going to find the average rate of change. So the change in dollars, or the change in the cost amount, would be your y's over the change in the number of games. So I'm going to pick 2 points, and we can pick any 2, but I'm going to choose the first 2 in each column there. So if I look at my total cost, I want to figure out what is the change in price over the change in the games. So I'm going to take 156, subtract 78, that is the change in y's, change in the money, over the change in the games, 4 minus 2. So the change in price went up by $78, and the change in the games was 2. So if you divide that out, that's $39. So what does that mean? That means the rate of change was $39 per game. So change in y over the change in x. So this one with the floor tiles and the surface area, I want you guys to try this one in your notes. You can pause the video. Again, pick 2 values, 2 x values, 2 y values that are corresponding to that. Find the change in y over the change in x and explain the meaning of that rate of change. And we will check that in class on Monday. Then we have to figure out if we have a table of values, is it a linear function? So remember, linear meant it creates a line when it is graphed. So a rate of change is constant for a function when the rate of the change is the same between any pair of points on the graph. So linear functions have a constant rate of change. So this is important. And we'll talk about what a constant rate of change means. So we look at the x values and you look at the y values in the table. So you can tell that the x values, to get from a 1 to a 4, it increased by 3. Okay, we added 3. 4 to a 7, we also increased by 3. 7 to 10 increases by 3. 10 to 13 increases by 3. So far our x's are the same number. That is constant. You also have to check the y values. So from a -6 to a -8, it subtracted 2 because it got into the higher negatives. 8 to 10, again, subtracted 2. 10 to 12, subtracted 2. -12 to -14, subtracted 2. So the y's have a constant rate of change as well. So this means, yes, it is linear. And you could say the rate of change is constant. Just so you know how to write that, it would be the change in y's over x's. So the change in the y was -2, the change in the x was +3. So that is the rate of change. So this one is linear. Let's look at letter B's table. So look at the x's, -3 to a -1. Well, that goes up by adding 2. -1 to +1, again, increases by 2. 1 to 3 plus 2, 3 to 5 plus 2. So far we're good. Look on the y's. So 10 to 12 adds 2. 12 to 16 adds 4. 16 to 18 adds 2. 18 to 22 adds 4. So notice the y values are not the same number. It went up by 2, then it went up by 4, then 2, then 4. That was not constantly the same number like the x's, always increased by 2. So this is not linear. And you would say the rate of change is not constant. So make sure you check every value of x and every value of y. Because it could seem that it is going well, it is constant, but then one number throws it off. Alright, so using that information, once my slide switches here. Alright, match the table with the rate of change. So you have A, B, C, D options here. You have 4 tables. Use the example that I just talked about because I gave you one example and one non-example to match up these rates of change with their table. Or there could be one that is not a rate of change, or the rate is not constant, so that might be one of the answers as well. So you try that, we'll check that on Monday. Let's talk about the amusement parks here. So the graph shows the number of people who visited U.S. theme parks in recent years. Part A, find the rates of change from 2000 to 2002 and also from 2002 to 2004. So we're going to use some information from the graph this time instead of a table. So for 2000 to 2002, so that means I'm using, for the year 2000, there was 317 million people. And in 2002, there were 324 million people. So I'm going to use those two ordered pairs, so to speak. I want the change in the y values. So the attendance is the y, the year is the x. So I want the change from 324 to 317, and that difference is 7. Over the change in time, so the years are at the bottom, and we want the change from 2002 to 2000, which is a difference of 2 years. If you divide that out, you get 3.5. So this is 3.5 million people per year. And let's jump down to part B here, and then I'll go back and finish the other year. Explain the meaning of the rate of change in each case. So that means the attendance at the amusement park I'll just say park for short, increased by 3.5 million people. Well, 3.5 more hold on a second. Sorry, the wording's off on this. Let me fix this. Let's start over. So the attendance at the park increased by 3.5 million more people per year. All right, and lastly we have 2002 to 2004. So now I'm looking from how it increased from 324 million to 325 million. So obviously you should know that that difference was only 1 million more. So 324 is a difference of 1. And over the years, 2004 to 2002 was a difference of 2 years. So this is 500,000 people per year. So kind of similar meaning. The attendance at the park increased by 500,000 more people per year. And part C, how are different rates of change shown on the graph? So you can see by the way the lines are drawn right here versus this part, you can see the blue one from 2000 to 2002 is much steeper than the other one. And even in this last section here, it's even more steep. So the steeper the slope, the greater increase of attendance. All right, and the last question we'll talk about on Monday. It's talking about tickets, Houston Astros tickets, the average price over some time. So we'll talk about that on Monday.